Okay guys, so I'm going to remind you to watch this video first, even though it's part 2. I'll make sure I put it first in my list, because this one's going to be most likely easier to grasp than the first one. Okay? And that's probably where some of you guys got scared. Your teachers actually put some of the harder ones first. Anyways, you'll see what I'm talking about as we go through this. Alright, so this is part 2. Guys, how am I going to basically graph x squared minus 16? Well, hopefully you recognize that as a difference of two squareds. So the first thing, first of all, notice it's x squared. You should know it's going to look like this. It's going to go up on the right. It's going to go up on the left. Why? Because that's what positive x squareds always do. Second step is, this is what we mean by end behavior, by the way. Okay? So we know what the end behavior is going to be on the left and right end of it. Now, what about everything in the middle, basically, right? The way we're going to solve that right now is we're going to always factor. So step 2, you're going to factor. Now, as I was saying, this is the difference of two squares. So hopefully what I'm doing is not going to blow your mind here. I know x times x is x squared. 4 times 4 is 16. I need 1 to be a plus, 1 to be a minus to get to negative 16. And if we solve for 0, that's how we find our intercepts. We know we have a negative 4 and a positive 4 is our intercept. So guess what? Let's graph them. Negative 4, positive 4. Now, just for clarity, if you did happen to watch the other video already, we also could plug in 0. And this will always help us find the y-intercept. Notice our y-intercept is going to be negative 16, which is way down there off our grid that they gave us, right? The thing is, guys, don't panic that you can't graph that key point. This is all your teacher wants. He or she wants you to discuss the end behavior, this right here. He or she wants you to factor it and find the intercepts and plot those. Step 3 basically is to do a rough sketch. A rough sketch, not a perfect sketch. So basically we know it's going to go up like this. And it's going to come down here. We know it's going to go way down here to at least negative 16. So it's going to go way down there. And it's going to come back up here. And then it's going to keep going up and to the right. In other words, we're going to get a parabola. And if you do all of that, guys, you should get full credit. Because right now, your teacher, he or she only wants a rough sketch. All right, let's do a few more a little bit faster, hopefully. Guys, do you recommend or recognize difference two squares again? Again, before we get that, do you recognize that it's an x squared and it's positive? So I already know it's going to do this, it's going to do this. Now the question is, what's it going to do in the middle? Well, we're at least going to find out where the intercepts are there and there. And the way we're going to do that is, if I take that right there, do you agree I can do 2x times 2x, 5 times 5, do a plus and a minus, and now I can set that equal to 0. So 2x plus 5 equals 0 only if 2x equals negative 5, and x therefore is negative 5 halves. 2x minus 5 equals 0 only if 2x equals 5, therefore x equals positive 5 halves. Now here's where you probably get your calculator out. Negative 5 divided by 2 is negative 2.5. See my big black dot at negative 2.5. 5 divided by 2 is positive 2.5. So I just graphed my intercepts. I know my end behavior. It's going to go up like this. It's going to go up like this. In the middle, it's just going to loop and come down, something like that. Now, this vertex, guys, is actually way further off the grid they gave you again. So again, you don't have to do that. All they want is what I just showed you. They just want a rough sketch. Do you know the end behavior, what basically the shape's going to look like? Can you find the intercepts? That's all the teacher wants. Okay, check this one out. Believe it or not, guys, it's a positive x squared again. So we already know that's going to go up on the left, up on the right. It's basically going to look like that. The only thing else your teacher's going to want, can we find at least the intercepts there and there? And we're going to go one step further since it actually works out nice. But anyways, guys, believe it or not, we can factor that. Check this out. 2x times 2x. 1 times 1. Notice my inner loop is 2x. My outer loop is also 2x. So I can get negative 4x if I make them both negative. Like so. So, this is the factored form, guys. Now, let's solve for 0. When is 2x minus 1 equal to 0? By the way, the factoring I did is my way of factoring. If you want to use the X method, that's a separate video that I've taught you and done for you. Look it up. All right? Factor with the X method if you like. Hopefully you're understanding how I came across this way. But anyways, solving for 0, 2x has to equal 1. X must equal 1/2, which is 0.5. See how I put a big dot at 0.5? Now here's what's interesting about this one. Do you agree that both of these roots, these factors I should say, are exactly the same? It's really a 2x minus 1 squared, isn't it? Now, some teachers call this multiplicity, but because it's a squared root, a squared factor, what that means is it's just going to touch at that point. So guys, you ready for this? Here's our answer. We only have one intercept. This is actually what we also call a double root. It was squared, right? We only have one. So this is what it's going to do. It's going to go up like this, and it's going to be really sharp because of the positive 4x squared, okay? And because of the double root, that too means it's going to bounce there. We know it's going to bounce. Hopefully you can see that. It's just going to touch. It's going to bounce at that value 1/2 or 0.5. So this is our graph. It's basically going to be the vertex. It's just going to touch there. Okay? How do I know that again? Because of this even power. That's what even powers always do. They bounce at that critical point. All right? Let's see if I have another one here. Yes, I do. This is the last one. Believe it or not, guys, your teacher gave you another positive x squared, so we know it's going to go like that. Remember in the next video, if you haven't watched it, negative x squared, the first one's going to go down like that instead. But this is what we got. Now let's factor it. You ready? You could do the X method again. I'm just going to do it my way. X times X is X squared. 1 times 1 is 1. I know minus 1 is minus 2. That's basically my inner and outer loops are both going to be negative 1x's, okay? And that gives me negative 2x. We have another double root. This time our double root, our x minus 1 squared now, if I solve for 0, means x is 1, right? So I'm just going to put a dot at positive 1, and it's going to go up on the right and up on the left because it's a positive x squared. And we know it's going to bounce right there. That's another thing that they may refer to it as, your teacher, he or she. We know it's going to bounce because of the even power or because it's a double root. Okay? But that's all there is to this so far, guys. Hopefully, if I don't have time to make another video on this later tonight, and there's a possibility of it, guys, I hope this is good enough to keep you guys going. All right? I'll see you around. I'm doing the best I can. Hopefully, I'm helping you guys out. See you around.